Okay, welcome back once again to all my dear students. Today we are going to discuss about the overlapping of atomic orbital. That is how many different types of overlapping, that is a positive overlapping, then negative overlapping and zero overlapping is there, right? But before starting that, let us revise the topic which we had discussed yesterday, that is the valence band theory. Who has presented the valence band theory? That is the Hitler and London, right? And who has developed it? That Pauli and Slater, right? What is this? That the half-filled atomic orbitals are coming close to each other. There will be overlap, and the bond which can be formed, that bond is said to be the covalent bond, right? But sometimes we can say that one atomic orbital is completely filled and other atomic orbital is half filled. When such two atoms are come close to each other, it will be overlap the atomic orbital, and whatever the bond is formed, that is called the specific covalent bond. We can also say it is a coordinate covalent bond. Then we have take the example, just like a hydrogen atom is there, atom A and atom B. The nucleus of atom A is Na and electron is Ea. Same way nucleus of atom B is Nb and electron is Eb. Now you all know that there is a attraction and the repulsion force is there between the same molecules and between the different molecules or atom, right? For the same atom, if there is attraction is there, then we can say NaEa and NbEb. If one atom nucleus and second atom the electron is there, then NaEb and NbE, right? There is an attraction. And where is the repulsion? The repulsion is there between the NB and EAEB, right? We have also discussed that the attraction force is more as compared to that of repulsion. The magnitude of the attraction force is more, and that's why we can say that the two atoms are come close to each other up to such an extent in which the potential energy will become minimum, right? And we can say that the attraction force nullify the what? That is, it will reach the equilibrium to the repulsive force. Okay, so that's why we can say that until it reaches the equilibrium, it will come close to each other. As you all know that hydrogen atom, if we take, then between the two hydrogen atom, whatever the distance is that is called the bond length, and it is a 74 picometer, right? Then after we have also discussed about the assumption of valence band theory. First, he says that the strength of the bond length of bond depends upon the magnitude of the overlapping. Means it is directly proportional to the magnitude of the overlapping. If more overlapping is there, then the bond is very strong. Second point, that there is a less energy difference between the atomic half-filled atomic orbital. Third point, that is the proper symmetry is there, right? Whatever the overlapping is take place, the overlapping is take place in such extent so that it can form a chemical bond, right? So all these things you have to know that we had discussed yesterday. Now, today we are going to discuss that is the overlapping of atomic orbital. Let us see. Next point, overlapping of atomic orbital. Atomic orbital. Let us see. Now, first we can say when two atoms come close nearer to each other, there is an overlapping in an atomic orbital, right? So first point, when two atoms come near to each other, atom come near to each other, right? There is overlapping of atomic orbital. There is overlapping of atomic orbital. Atomic orbital. जब दो एटम एक दूसरे से नजदीक आते हैं तो उसके जो ऑर्बिटल है वो ओवरलैप होता है. And whatever the bond it can form, that bond we can say it is a chemical bond or covalent bond. See, next one. Can also say this overlapping can be positive, negative or zero. This overlapping will be positive, negative or zero, which is depend upon the property of overlapping atomic orbital, which is depends upon the properties of overlapping orbitals. Now let us see that what is positive overlapping, what is negative overlapping, and what is zero overlapping. Let us see here. First of all, here I write here positive overlapping. Right? Then here negative overlapping. See here. Let us suppose first one, that is overlapping of an orbital. Right? So positive overlapping means positive, positive, negative, negative. This we can say PZ, PZ. Right? Second one, let us suppose here. Here positive, positive, negative. So here PZ and S overlapping. Right? Here is a Z. And last, then next one. Positive, positive, negative, negative. This we can say PX, PX overlapping. Right? And here also positive overlapping, and here it is a negative overlapping. See here. Okay, so here positive, positive, negative, negative, and this we can say P by P by. Okay, so all this we can say it is a positive overlapping. Now, let us take the second example, that is a negative overlapping. Right? Here positive, negative, negative, positive. Right? So this we can say PZ, PZ. Next one. Just like this. Here negative, positive, and here positive. So this we can say PZ and S. Right? Then here Z, here also Z. So Z. Here positive, negative, negative, positive. So this we can say PX, PX. Right? And last one. Here positive, negative, negative, positive. Z, PY and PY. Right? Last one. We can say it is a zero overlapping. Zero overlapping. Now what is zero overlapping? See here. Positive, negative. Here positive. So here PZ and S. Same way. Positive and negative, positive and negative. This PX and this we can say PY. So such a type of the overlapping we can say it is a zero overlapping. So here overlapping are three different types. That is either positive, negative, and zero overlapping. Okay, so note down all these things, how many different types of overlapping is there, and then after we are going to discuss about the geometrical shape, the assumption of overlapping. First of all, write down all these things. Okay, now let us say that the assumption of overlapping orbital, the assumption of overlapping orbital are applicable similarly to what similarly to homonuclear, then we can say heteronuclear, then diatomic and polyatomic molecules, diatomic and polyatomic molecules, right? Let us take the example, the chemical bonding in the molecules having a polynuclear atom. The chemical bonding of the molecules having polynuclear atom, like a polynuclear atom, like a CH-4, that is methane, NH3 and H2O, right? Can be explained with the help of Valence band theory. Can be explained with the help of Valence band theory. Understand BBT? Okay. As you all know, the shape and the bond angle can also be known with the help of Valence band theory. Now you all know that the shape of CH4, that is equals to tetrahedral, right? Shape of NH3, that we can say pyramidal, and shape of H2O, that is band, right? All these things you can explain it with the help of Valence band theory. Now, what is that? Let us suppose if we take the methane. In the methane, carbon is a central atom, and if you want to write down the electronic configuration, then it contains the 4 unpaired electrons are there, right? All the 4 unpaired electrons can overlap with the 1s orbital of hydrogen atom, 4 hydrogen atom, and thus whatever the bond it can form, that bond is said to be the sigma bond. See here, I can write down here that in methane molecule, the electronic structure, the structure central atom of carbon in methane CH4 molecules, the central atom, the electronic configuration of central atom carbon is in excited state is 1s2, 2s1, 2px1, 2py1 and 2p. So all the 4 unpaired electrons are there, right? So the 4 half-filled orbital of carbon atom overlap with, thus the 4 half-filled orbital of carbon atom is overlapped with what? 4 hydrogen atom. It will be 4 hydrogen atom which are also half filled. 4 hydrogen atom which are also half filled. Understand? So it will be overlapping the 4 hydrogen atom and forms 4 CH bond and forms 4 CH bond, right? And now, as you all know that the overlapping will be take place here, the shape of the methane molecules, that is here is the central atom, this is the 1, here 2, here 3, and here 4. This will be overlapping the hydrogen atom, 1s orbital of hydrogen. Here also 1s orbital of hydrogen. Here also 1s orbital of hydrogen. And here also 1s orbital of hydrogen. And it can function as the hydral shape, right? So this is how the overlapping of the orbital will be take place, and thus it can function, right? Is it clear? Note down all these things, right? So same way, here in ammonia also 1 electron of nitrogen atom and 1 of hydrogen atom overlap with each other, and whatever the bond it can form, that bond is said to be the sigma bond. Now after this we have to study about the sigma bond as well as the pi bond. Note down first of all this. Next point, that is the types of overlapping and nature of covalent bond. Types of overlapping and nature of covalent bond. Types of overlapping and nature of covalent bond, right? Let us see. First of all, there is a sigma bond, and then after we are going to discuss about the pi bond. Let us see what is sigma bond. Sigma bond means this type of sigma covalent bond is obtained by end-to-end overlap of atomic orbital, right? Let us see that this type of sigma bond is obtained by end-to-end overlapping of the what? 2 atomic orbital having internuclear axis. 2 atomic orbital having internuclear axis, right? So this is called what? Sigma bond. It is also called axial overlap. It is also called axial overlapping. See here, end-to-end overlapping is there. So here the more amount of overlapping will be take place. The magnitude is more, and that's why whatever the bond it can form, that bond is very strong, right? So here we can also say that overlapping, for example, S overlapping. Let us see that S overlapping. एग्जाम्पल लेते हैं हम, तो पहला ओवरलैपिंग of s dash s orbitals. चलो s dash s ऑर्बिटल का ओवरलैपिंग देखते हैं. तो यहाँ पे एक s ऑर्बिटल है, इट इज स्फेरिकल इन द शेप, और ये दूसरा s ऑर्बिटल है, राइट. यहाँ पे s ऑर्बिटल and this is also s orbital. अगर ये ओवरलैप होता है तो whatever the bond it can form, this we can say s dash s overlapping. Understand? And whatever the bond it can form, that bond is said to be the sigma bond. Next, second example, that overlapping s dash p orbitals. So here one is s, it is a spherical in the shape. Second one is a p. Understand? Dumbbell shape. This is s orbital. This is z orbital, and overlapping will be take place. So you can get what? So here this is s and s dash p overlap, right? Is it clear? So here s dash p overlap. Right? Then second example, p dash p orbital. चलो p dash p overlapping, that means यहाँ पे p, second is also p, overlapping is there. So यहाँ पे, right? So here this we can say p orbital, here also p orbital, and this we can say p dash p overlap. Understand? So see, whatever the bond is formed, end to end overlapping will be there, and whatever the bond it can form, that bond is said with the sigma bond, right? These things we have to know, that this we can say it is a sigma bond. Why? Because end to end overlapping will be take place. Is it clear? Now let us discuss about the pi bond. Let us discuss about the pi bond. ये सिग्मा बॉन्ड हो गया. Now pi bond. What is pi bond? Pi bond. Yes, first of all definition. In this type of pi covalent bond formation, in this type of pi covalent bond formation, we can say that the axis of atomic orbital that are overlap remain parallel to each other and perpendicular to its axis. Axis is parallel to each other as well as the perpendicular to the axis, right? So let us find out that the axis of atomic orbital, the axis of atomic orbital are parallel to each other. Orbital overlapping is parallel to each other. Parallel to each other, and we can say it's perpendicular to the internuclear axis, and it is perpendicular to internuclear axis. Understand? Here side by side overlapping will be take place. So whenever the orbital Side by side overlapping is there, it is a parallel to each other and perpendicular to the axis, then we can say that whatever the bond it can form, that bond is said to be the pi bond, right? So let us see about the pi bond. Here positive, negative, here also positive, negative, overlapping will be take place. Right? Here positive, positive, negative, negative, and this we can say px, px, right? And whatever the bond it can form, that bond is said to be the what? Pi bond. The strength of any type of sigma or pi bond is proportional to the strength of any type of sigma or pi bond is proportional to the magnitude of overlapping of atomic orbital राइट? जितना ओवरलैपिंग ज्यादा होगा उतना ही बॉन्ड स्ट्रांग बनेगा, राइट? सो दिस थिंग्स वी हैव टू नो. इन सिग्मा बॉन्ड फॉर्मेशन overlapping of atomic orbital is more. Can I write down here that in sigma bond formation, the overlapping of atomic orbital is more. As a result, the sigma bond is more strong than pi bond. Sigma bond is more strong than pi bond. Understand? Now, the most important thing, that who will make the sigma bond? Sigma bond, there is a overlapping will be take place, as well as the pi bond. Which type of overlapping will be take place? So in the sigma bond, first of all we can say S overlapping, PZ overlapping, and PZ overlapping. So this type of overlapping will be take place, then it can form end-to-end overlap, and thus whatever the bond it can form, that bond is said to be the sigma bond. Whereas in the pi bond, we can say PX overlapping and PY overlapping. This overlapping we can say side by side overlapping, right? Parallel to each other and perpendicular to the internuclear axis. So whatever the bond it can form, that bond is said to be the pi bond. But the overlapping strength, the magnitude of overlapping in the pi bond is less as compared to that of a sigma bond, and that's why we can say that the sigma bond is as strong as compared to that of pi bond. Understand? So all these things we have to know. Is it clear? So up to here, it's enough. In the next video, we are going to discuss about the molecular orbital theory. Today we have discussed about the overlapping, types of overlapping, then types of bond, the sigma bond, pi bond, which type of overlapping, there is a positive, negative, zero overlap, right? So all these things we have to know, right? So thank you very much.